This is SpaceTime Series 24, Episode 123, for broadcast on the 29th of October 2021. Coming up on SpaceTime, the Large Magellanic Cloud cannibalizing smaller galaxies, NASA's first test of optical communications technology, and OneWeb's mega broadband internet constellation passes the halfway mark in satellite launches. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
Scientists have confirmed that the Large Magellanic Cloud has been cannibalizing smaller galaxies. The Large Magellanic Cloud is a satellite dwarf galaxy which orbits the Milky Way. Astronomers already knew that large galaxies like the Milky Way grow by merging with or cannibalizing other galaxies. Both the Sagittarius Dwarf Elliptical Galaxy and the Canis Major Dwarf Galaxy are currently being stripped of stars and gas by the Milky Way. And there are gravitational tidal trails now stretching from both the Large and Small Magellanic Clouds into the Milky Way. But now a report in the journal Nature has shown that even a small galaxy like the Large Magellanic Cloud has in turn absorbed even smaller galaxies in its vicinity. Using both the Magellan and Very Large telescopes in Chile, the authors studied 11 globular clusters in the Large Magellanic Cloud, looking for differences in their chemical composition compared to the rest of the cloud. Globular clusters are tightly bound spheres containing thousands to millions of stars, which were all originally formed at the same time in the same molecular gas and dust cloud. And there's growing evidence that they could be the surviving cores of ancient long-gone galaxies. Globular clusters are commonly found in the halo of galaxies. The Milky Way has at least 150 such globular clusters orbiting around its halo. The idea is that the core of a globular cluster can hold together even after billions of years of gravitational pushing and pulling in a galaxy. As the authors studied their 11 globular clusters in the Large Magellanic Cloud, they found one, NGC 2005, which had a distinctly different chemical composition. This cluster contains around 200,000 stars and is located about 750 light-years from the center of the Large Magellanic Cloud. Among other things, the stars in this cluster contain less zinc, copper, silicon and calcium than stars in the other 10 clusters that were studied. Now, based on the chemical composition of NGC 2005, the authors have deduced that the cluster must have been a relic of a small galaxy in which the stars formed rather slowly. Billions of years ago, this small galaxy would have merged with a then not-so-large Large Magellanic Cloud, adding to its overall mass. Over time, most of this small galaxy would have been pulled apart and its stars scattered. But the central globular cluster, the galactic core, which we now call NGC 2005, has remained intact. This is SpaceTime. Just a reminder that SpaceTime is designed to provide accurate and educational science news and information accessible to everyone. And you can help support our work by becoming a SpaceTime patron. And this gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com and click on the Support SpaceTime button. Still to come, NASA's about to undertake its first test of a new optical communications system, and OneWeb's mega broadband internet constellation passes the halfway mark in satellite launches. All that and more still to come on SpaceTime. NASA is about to test a new optical laser communication system in space for the first time. The Laser Communications Relay demonstration is gearing up for launch next month, with a payload now fully integrated into its host satellite and ready for its final testing before being lofted into orbit. The instrument works by using higher frequency infrared light encoded into invisible laser beams rather than radio waves in order to send and receive information from one location to another. Because of their high frequencies, lasers can transmit far more data in a single downlink. They're also physically smaller in size, in mass, and have lower power requirements, making them ideal for use in spacecraft. As part of the final testing campaign, NASA technicians have integrated the last pieces of hardware, completed final inspections, and conducted launch integration system tests. The mission is slated to launch around November the 22nd aboard a United Launch Alliance Atlas V 551 rocket from Space Launch Complex 41 at the Cape Canaveral Space Force Station in Florida. The spacecraft will be part of the U.S. Department of Defense's Space Test Program Satellite 6, which will be placed into geostationary orbit. This report from NASA TV.
Since 1958, NASA has relied on radio wave technology to talk with missions in space. Today, we're developing a better way to get spacecraft data back to Earth. That's where the Laser Communications Relay Demonstration, or LCRD, comes in. Built and managed by NASA's Goddard Space Flight Center, LCRD will send and receive near-infrared laser beams to and from Earth. As NASA's first long-duration test of optical communications technology, the mission aims to perfect space and ground-based technologies. So why lasers? Laser communications can transmit up to 100 times more data per second than previous systems by using a shorter wavelength of energy. With this increased bandwidth, missions can send larger files and even live high-definition video from space. Laser communication systems are smaller and more efficient than radio wave technology. They leave more room for science instruments, are cheaper to launch, and require less energy on board the spacecraft. These benefits extend to receivers on the ground. Earth-based laser communication receivers can be up to 44 times smaller than the current radio antennas. LCRD is the next step in making these technologies a reality, helping NASA to push the boundaries of scientific discovery and exploration. Eventually, NASA will integrate this technology into future missions, as well as share it with commercial companies.
This is SpaceTime. If you want more SpaceTime, don't forget to check out our blog. There you'll find all the stuff which we can't fit in the show. There's heaps of images, news stories, there are videos, and there's lots of funny things I find on the web. Just go to spacetimewithstuartgary.tumblr.com. That's all one word and in lowercase, and that's Tumblr without the E. Still to come on SpaceTime. OneWeb's mega broadband internet constellation passes the halfway mark in satellite launches. And later in the science report, the US State Department provides details on America's current nuclear weapons stockpile. All that and more still to come on SpaceTime. OneWeb have launched another 36 broadband internet satellites into orbit. The flight aboard a Soyuz 21B rocket from the Vostochny Cosmodrome in Russia's Far East brings to 352 the number of OneWeb satellites now in orbit. The company plans to operate an initial constellation of 648 of the 150-kilogram Ku-band spacecraft in 1,200-kilometre high orbits. But as has been the case of late, this launch comes as concerns continue to grow over the damage constellations like OneWeb and SpaceX's Starlink are doing to important scientific astronomical research, with trails of these internet satellites polluting the skies, making astronomical observations more difficult. This is SpaceTime. Hey, if you haven't had a chance yet, go and check out our SpaceTime store. Everything that we sell there helps support our program. And there's a huge range of promotional merchandising goodies to choose from. These range from jumpers and t-shirts to coffee mugs and neck chains. In fact, there's something there for the geek in all of us. Just go to spacetimewithstuartgary.com and click on the shop button. And time now to take another brief look at some of the other stories making news in science this week with a science report. Scientists have discovered the first fossil evidence of modern human remains on the Indonesian island of Sulawesi. The remains date back to the Pleistocene era, which ended around 12,000 years ago. A report in the journal PLOS ONE says the island is a key location in science's understanding of how modern humans would have moved between Asia and Australia. The lack of fossilized human remains from this region meant that the knowledge of how humans first moved into the region and then moved between the islands is limited. The authors say the new finds could fit in with several different models of migration through the region. And while it can't give a definitive answer on which model's right, it's still of value because it shows that early modern humans were present in a region that may have hosted multiple species of ancient humans. The US State Department has published details on America's current nuclear weapons stockpile. The data shows that as of September 30, 2020, the United States military maintained 3,750 nuclear warheads. That's down 55 from a year earlier and 72 less than in 2017. It's the lowest level since the US nuclear stockpile peaked at the height of the Cold War with the Soviet Union in 1967. Back then, America had 31,255 thermonuclear warheads. Meanwhile, a report from the Stockholm International Peace Research Institute, which also includes retired nuclear warheads not included in the State Department's numbers, shows that as of January this year, the United States actually had 5,550 warheads. That compares to Russia's 6,255, at least 350 in China, 290 nuclear warheads in France, 225 in Britain, 165 in Pakistan, 160 nuclear warheads in India, and 45 nuclear warheads in North Korea. Israel, which was the sixth country in the world to develop nuclear weapons but doesn't acknowledge its nuclear forces, is believed to have somewhere between 90 and 220 thermonuclear weapons. A new study suggests that horses may have first been domesticated in the Volga-Don region of what is now Russia, before spreading across the rest of the world 4,200 years ago. A report in the journal Nature found that a specific genetic profile began to spread around the world at this time, replacing all the wild horse populations from the Atlantic to Mongolia within a few centuries. The authors found two key genes that were different in this horse. One is linked to more docile behavior, and the second indicates a stronger spine, suggesting that horseback riding was an important part of the rise of these horses. The authors suggest that these characteristics ensured the animal's success at a time when horse travel was becoming global. Psychologists say it's really not all that weird to feel schadenfreude when COVID-19 deniers end up getting COVID-19. The more religious might even describe it as divine justice, but of course you should always remember that every COVID death is a disaster for family and friends. Tim Mindham from Australian Skeptics points out there are lots of websites dedicated to mocking those who denounce or defy public health measures like vaccines, mask wearing and social distancing, and then later die of COVID-19 infections.
Yeah, I mean, psychologists are saying it's not quite as evil as you might think. And for those people who don't speak French, Schadenfreude is German, obviously, and it means sort of taking some pleasure in someone else's misfortune. But in many cases, it has an extra element to it, and it's sort of taking pleasure in someone's misfortune when then they deserve it. They get their just desserts sort of thing. So therefore, I think people do have this thing about, some have described as cruel, as taking pleasure when someone else gets COVID, especially someone who's been saying COVID's not real. The real element comes in is when someone who's a major influencer, like a politician or a radio shock jock or a podcaster or whatever, who has been making continual claims that the vaccination doesn't work, that COVID's not real, etc., and then comes down with it and says, if only I knew. And if I would have taken the vaccine if I knew I was going to get sick. Yes, and that's when Schadenfreude really comes in and you say, yep, I don't feel sorry for you at all. In fact, I feel quite pleased. Enjoying someone else's misfortune is not exactly the most ethical way to go. It's certainly not the most empathetic way to go. You don't really take enjoyment if someone gets hit down by a bus. But in these particular cases, we're looking at COVID, people who are COVID deniers, active COVID deniers and influential COVID deniers who then catch COVID and then say, I made a mistake. And they say, well, you know,
Oopsie.
Good for you, too bad for everyone else who followed you. So, yeah, don't feel too bad about it. It's normal, apparently. It's a quite a common reaction to make yourself feel better if someone else is doing badly. In the cases of COVID deniers, especially politicians, very public COVID deniers, in a way, you think, yep, you deserve that. And yeah, it's not nice sometimes you just got to think, do you really deserve that?
That's Tim Mindham from Australian Skeptics. And that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favourite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details. And if you want more SpaceTime, please check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as heaps of images, news stories, loads of videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, @SpaceTimeWithStuartGary on Instagram, through our SpaceTime YouTube channel, and on Facebook, just go to facebook.com/SpaceTime with Stuart Gary. And SpaceTime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.